Hello all, we are studying about the streams in Java and in Java and today we will first start with an example. So what is the ask to you? So this is the given problem statement or the ask to you. Yes. So you have given an inventory of cars. So you have given cars. You have to identify all the cars that are greater than the 4000 millimeter and you have to tell the names of all these cars in the sorted order and sorted by their length. So these things you have to achieve. So let's start first how you are going to write that particular logic. So let me open the project here, Modern Java. Cool, we are on chapter number 4. We are studying about the streams. Me. So first, I will copy the methods of getting the car inventory from the chapter number 2. So in the mean, we have written a methods to get the car inventory. This is the method. And here we are writing our mean method. Now first we are getting all the cars. Cars is equal to get car inventory and this is the list of cars. Okay. Now what we had to do, we had to achieve first the filtering of these cars. So list car filter is equal to new array list for car in all the cars and then we will filter the cars which are greater than in the length 4000. So if car dot get length is greater than 4000, in that case what we are going to do, we are going to dump into the filter cars. Now we have to sort these cars. What are the cars we get in the filtered cars? So let's better name it as the filtered cars. Now filter cards dot sort ko you have to provide new comparator operation and then you will compare return int is dot compare o1 dot get length or 2 dot get. So based on that you will sort different cards. Now your cards are being sorted on the length and now you only need the name and the and then result is equal to new array list. You will iterate for each of your filtered results. So your car in the filtered cars result dot add car dot get name and here you will return the result. So better I will move this whole logic in a method. Public list of string get car names and what you pass is the list of the car. Here you have all the cars and then you write here they are logic. Right, and at the last you return this particular message. So what are the challenges? You have to write a long complex codes to perform these particular operations. So let's write the things that we have achieved here. First, this code is complex. So as we have not yet compared it with the another version. So right. And here we are specifying how an operation should be achieved. So that is the philosophy that our method has followed. Sun is not achieving the parallel. No parallelism. No parallelism. So these are the common problems that you have observed in this particular methods. Let's write another methods using the string. So syntax of methods will be almost the same. We will just change the names using string. Now write its implementations. So you get the cars dot stream dot filter by car dot get length greater than 4000. Now again we are doing the sort dot map. So now you can see the whole code that we have written here. It is written here in those some simple lines. So now write the what are the advantages we observed here. First, this code is concise. I will say it is the concise and simpler. Second, focused on what to do. Third, it can be parallelized without writing the complex thread and locking concept. So what you have to do here instead of saying dot parallel stream. So if your machine has the multiple cores, it will automatically take the advantages of that. So I hope now the difference is clear. Now it will gives you the more intuitive definition why you should actually study it about the streams. But yeah, before doing that, actually I need to run this particular method from the main method so that at least you are sure that it is working. Right. So let list of string car names is equal to get. Sorry, why it is not getting because the methods is not public static marked, and here the cat car streams cars we passed and the print the car names. Without not println of car names. Let's run this particular method. Oh, some compilation error. Let's find out what's went wrong. In chapter 2, car cannot be cast into the comparable. Car is a so here the sort name cannot be comparable because we in the sorted we didn't specify how it need to be sorted. Car dot get length. I hope that will work, and that is not working. Expected to, but fine. Okay, so it is expecting C1 and the C2, that is the car 1 and the car 2, and how you are going to compare. So I will write the integer dot compare C1 dot get length and C2 dot get length. Let's try to run this method again. Yeah, So our cars got sorted by their length, and then we got the names. Let's Now let's study it about the stream. What is the actually the stream and how you are going to define it. Let's run this screen. So there are the two different concepts. First concept is collection, and second concept is stream. Whenever you're talking about the collections, it is a DS data structure. It is a data structures, and it is more focused on how to store the data and how to access the data. So it's primarily focused on the storing and the accessing of the data, where the stream is primarily focused on the computation. How can be computation can be done efficiently. And it is a declarative approach, creative approach. It means it more focus on what to do. So for example, in the example that we have just taken, so you have only specified what you actually want to achieve. So you have these cars, you want to filter some cars out of it, then you want to sort it, then you want to change the car object into its names, and then you want to collect them into a list. Exactly, you define it in a declarative way. So that is you primarily focus on the declarative approach. And they can be processed in the parallelly on a multi-core environment without you being writing a code. So you don't have to write the codes with the threads and logs. So you don't have to come worry about the serializations, where to take the logs, how to run the to break the data into the give and assign that work to the different threads. It will be automatically handled by the streams. So I hope so far the definition is of the stream is being clear to you. Okay. Let me give an example here. So taking just the previous example, and streams allows you to do the manipulations using the building blocks. Building blocks. Right. So the operations that we are doing are the building blocks. So initially, let me change the color here. So take sky blue. So initially you are given certain cars. This is our stream. We converted it into the dot stream. You converted it into the streams, and behind that you applied certain building blocks for the processing on it. And let's say finally you done. See, this is also a building block, but I'm currently making it with the different terms. And you defined it a filter operation. Then you define a sorted operation, sort operations, and then you defined a map to transform the car into its name, and then you finally did a collect operation. So if you see, these are the independent building blocks that you can join and to make the pipeline bigger, stream pipeline. And that whole pipeline is known as the stream pipeline. Right. So initially you have some source of data. This is your source, and you finally perform certain operation. This is also operations, and whatever the output here, this is the result you get. I hope so far so clear. And to each of these operations, you generally whatever the where you do the processing, instead of this, you generally provide the lambda. You give this also take the input the lambda, this lens take the lambda, and in that you define how exactly you are actually want to perform that particular operation over the streams. Now to give the summary here of the stream. So stream is introduced from the Java 8 and it gives you following advantages. First, it is declarative. Declarative, it gives code becomes the more concise and readable or more focus on what to do instead of how to do that particular operation. Second thing, it is composable. It means it is very flexible to write. And if you are need to introduce something in between, it is very flexible. These are just building blocks. You have to join them building blocks. And on the first approach that we discussed, that without streams there, if you have to do change, you have to do a lot of code change. Third approach, third, it is parallelism. Parallelism. So for better performance, it will automatically take care of the modern multi-core CPU architectures in order to achieve the parallelism. So far so good, cool. So now we can start with we again start to understand the definition of the streams. Definition of stream. So definition of the stream can be defined as a sequence of elements from a source that supports data processing operation. So this is the formal definition, that is a sequence of elements from a source that supports multiple data processing operations. So that just we discussed, right? So what do you understand by the sequence of elements? Sequence of elements is mostly we discuss about the collections are primarily for the storing or the accessing data. Streams are mostly about the performing the computation operations. So it provides you collection of the data in the form of the streams, right? There will be some source, so this is some source, it will keep you giving on the data, and then you perform list of operations. So these are the different operations you performed over these, right? And what are the data processing operations? So most common known, for example, filters, map, reduce, find, match, and so on. We will discuss all those operations in the details in the next lecture, but this is in this section we will primarily understand the concepts. And these are the different operations that can be performed. What could be your source? Your source could be any collection, it could be your array, it could be resource IO. These are the different sources that are being possible. On these you perform, these starts giving each an element, and on each element you perform the operations. Now there are some characteristics characteristics of stream. So there are the two major characteristics we will discuss. First is the pipelining, and the second is internal iteration. So these are the two primary concepts, and it means what it exactly means. So the inter pipeline has two different concepts. It is has laziness and short circuiting. Don't worry, we will discuss those concepts into the detail. And internal iteration we also discuss in the detail. So first, let's say pipeline. So pipeline we have discussed. You have given a particular source, and after that you can append your operation one, operation two, operation three, and keeps on appending these operations. And then at the final, your terminal operations you perform, and that based on that you will get the output. So this is the pipeline you can define how it acts laziness and what is the circuiting we will discuss in this particular pipeline. And now what is the internal iterations, right? Internal iterations, so for example when you loop the for loop or the for each loop, these kind of loops you use, so you are these kind of iteration is known as the external iterations. And when the iterations on the object is done internally without you being knowing you have to write these codes, this is known as the internal iterations. So system itself does some certain internal iterations for you. Now let's take some another example. For example, this time you have given certain food items, and for each food items you know what is their calorie values. Okay, so you want the foods which are high in calorie values, the only three items that you want. You don't want to worry about the specific orders with the highest calorie, but let's say you want to do, you have given certain food. Based on that, you want to know the items which has calorie greater than the 300. You want their names, and you want only three as such items. So that operations you exactly want to perform, and how you will do achieve that particular operation with the streams. So let me write some code. For example, you have given the food items, and first thing you have to convert them into the stream. After that, you will do the filter, and to the filter, you will provide certain lambda expression. So let's say food is f, and you want to check if food dot get calorie is greater than 300. So it means you filter out all those items who has the calorie greater than 300. Then you want to transform their values. So instead of food object, I want just its name. So f dot get name. I only want such three objects, so I limit the three, and then I want to collect it and collect it into to list. It will automatically be turned into list, and this is you can assign to the list of string, and then the names, and then those names you can print, do whatever. So thing is, you write the declarative codes and you perform certain operations. So all these things we discussed in the operations. This is the operations. This is the source that we talk in all the examples. This is the source. These are the operations, and this particular is the terminal operation, which finally generates the output for you. Let's take this as an with diagram. So initially you are given certain, so this represent each of the different food items. Initially you has multiple food items, and then this is your stage one. This is representing the source. Then you go to the stage two, you perform the filter operation. So out of those, in the next stage you receive only those items which has calorie greater than the 300. Let's suppose you got all these four items. Now stage third, so let me write the here the method's name as well. You actually done the filter here, then you done the map, then what you actually do, you do the limit, and then you do the collect. And these operations you performed at this time. Now you perform the map operations. Instead of that object, you only converted it to its name. So let's say green circle representing the name instead of that particular your food item object. Now in the stage 4, that is our limit operations. You mentioned about the limit of 3. So instead of the 4, first 3 will be taken here. So you this, and this will be there, and this won't come. Now in the final S5 stage, what exactly happened here? So here we collect these objects, means these objects are put into a list, and that list is being returned as the output. So I hope that is being very clear to you. And we have also discussed about the how stream, what is the difference between the stream and the collections. So that is already being covered. Now another property of the stream that it is only traverse only once. What it exactly means? So for example, you have a stream, let's say food items only, dot stream, and you want to iterate over each of these. So one to iterate the operation this time we are doing is just the terminal operations, which will actually print each object. So you can write it like system dot out colon colon println. What it exactly does, it just take each object and just print it. Cool. Now you have iterated it once, but okay, let's say fs, I take it is like this, understand, take it is line 1, line 2, and line 3. Now I take the fs and again do this particular, and assume that this is the exact code. So what will happen if we have three food items in this particular food item list? It has, let's say, pizza, it has burger, it has chocolate, let's say it has all these items. First here all those items got printed, but whenever you iterate that particular streams again to print here, this time this will throw you error that stream has already been operated. What exactly it means? Your stream can only be iterated only a single time. Does it make sense? Cool. Now last time we have mentioned about two concepts. First is the internal stream and the external streams. So we want to understand little more about the internal stream and external stream. Right. So for example, you have to given a list of cars. So you have given a list of cars and you want only the names out of it. So what is the general logic that you will write here? So let's go to our code and then do it. That will be, I think, more intuitive. So for here, what I will do, I will take each car and what I will do here, the iterate over the cars. And I want to store the name of the car. So list of, let's say, string and names equal to new array list and names dot add equal to car dot add. So generally this is the code generally we all write, and this is known as the external iteration. External iteration. Why? Because you have actually written these particular iterations, you are iterating them explicitly, you are reading one item at a time and then extracting out the name out of it, putting it in the whole logic of the iterations you are doing by yourself. There's another way for doing the external iterations, and that is using the iterators. For that, what you have to do, you do the cars dot iterator, right? And then you assign it to an iterator object, iterator of string, and then it is iterator. Not sure what I am missing here. Okay, sorry. Car. And again, I want to populate the same name, so I'm not again declaring that I'm using the above one. So while iterator dot has next, till that time we are getting the car object. Car c is equal to iterator dot next and names dot add c dot get. So this is what we are doing here. So it means in the list of names we have populated all the names using through iterating through the iterator, and this is also then external iterations. Now considering this things, we want the internal iterations. Means I explicitly don't want to write the while or the for each loop in order to iterate over the collections, and so that is the internal iteration. So, sorry for the spelling mistakes. And now I just want the name of names. Names variable is already declared, so names. And we have the cars, done the streams, then the map, then c dot get name, and then the collector dot to list. And I just specify these operations, right? The collect here, I transform that particular streams and then collect, and it automatically give me all the names. Or previously, what I have to do, I have to write the for each loop. So this is known as the internal iterations. Now let's understand which of them is better. Cool. And why we should prefer the internal iterations. So for example, you have a small baby and you put all his toys, let's say toys 1, toys 2, toys 3, toys, right? So first time you tell to the baby that bring your toy number 4 and put it into the basket. So it goes, take the toy 4, put it into the basket. Now, so you go tell the boy that select the toy number T1 and put it into the basket. Now child come take this toy 2, put it in the basket, toy 4, put it in the basket. That's what exactly you are doing in the external iterations. But in case of internal iterations, you won't say that bring these toys. You says put all your toys in the basket. In basket. In that, what optimizations here it can do? It can, but chat can bring the two toys at a time in the hands. Probably these two are close, brings it together. And also it can bring the nearby toys first and then the far distance. And it means the idea is it can do the certain optimizations. Based on the data available, it can perform certain optimizations. It can plus it can do the parallelism. So overall, you get the operation fast. So that's why internal iterations is being preferred. But yeah, it exactly depends more on the use cases. So I hope you understand the concept of internal or external iterations. Now moving to the another concept, that is the stream operations. Stream operations. So before just we talk about the we have written and logic of converting all our food items into the its names and filter out which has the calorie greater than the 300. So let me write again. So for example, here we have the food items converted into the stream, and then we will do the some filtration, sorry, filter, and the filter we will pass the food items and get food dot get calorie if it is greater than 300. So this is our lambda expression. Lambda expression we have discussed in the last session. So if you are not very clear, you can watch the last section. And then we will do the map. Map do certain kind of a transformation. So from the f, we transform it to the f dot get name, not semicolon. And now we do the limit. Limit is 3. We selected the 3 objects and then we collected it into the to list. So these are the things we have actually done. And now we want to little bit understand this. So last time we discussed this is the source. This is our terminal operation, and all these operations are our intermediate operations. Intermediate operation. So you can keep on increasing. So it doesn't limit to the 3 or 4. So any number of the intermediate operations you can keep on adding in order to make your pipeline. So once any of the intermediate operations performed on the streams, they can be joined together, intermediate operations, to perform the operation continuously. And at the end, there will be somewhere the terminal operations need to be performed. So at the terminal operations, it closes your stream. It means you cannot add any of the intermediate operation performed after it. There is no further processing after a terminal operations being performed. So uh, let me rub it. So whenever we're talking about a terminal operation, so input is a stream and it output is stream. Right, so you keep on connecting the other. So other terminal operation takes in streams and keeps on outing a stream. So these are the intermediate operations. But whenever you take and terminal operations, it inputs a streams and outputs something. I won't say the stream, but the abject result which you have expected. That is it. Now another concept that you need to understand. We have talked about initially about the laziness. So what exactly it means? So until the termination operations is being performed, your stream no operations is exactly performed over the streams. So whenever the terminal operations is being performed, it is started. And whenever we talk about the limit operations, so for example, before that we had talked about, let's say you do a certain kind of filters, it resulted into 30, but you exactly expected, let's say, 4 operations. So it means previous operations won't be performed on the 30 objects. It will be only performed on the 4 objects. It is performed one at a time. So for example, here the number 1, 2, 3, and the 4, and let's say up to 30. So you have a list of integers as a stream. Over this you want to perform ban operations. So let's say you perform map where you are doing s into s start 2. So it means you're multiplying an operation by the 2 always and limit the 3, and then you finally do the correct. So what exactly it means? You get the first operations, you perform the map over it, you perform the limit on it, and then you going to collect it. So you got the 2 in the output. Then only the processing of the second will start. It will flow throughout, reach it, then collect the 3 till here, and then the 3. So you got the limit here. It will be short circuit, no further processing even above will happen over these results. You get the 4 and results will be performed. You are done. So this is the short circuiting concepts. You have short circuit before processing all the records. So I think these are the major concepts we have covered it today. And today we'll get to discuss about the different stream operations, how what is their functionality and how they need to be used into the course. I hope you like the